So in this lesson, we are going to talk about measures of what we call central tendency, which are the mean, the median, and the mode. There are two different ways that we can think about the, quote, center of a distribution. One way of thinking about it is thinking of the balancing point, like where the center of mass would be if you placed a fulcrum at the bottom of the graph, what would actually balance it out. And the other way is the literal halfway point, like what's in the very center, what value is in the very center if you lined up your data kind of from smallest to largest. So those are two different ways to think about it. The mean is the arithmetic average. So another word for average is just the mean. That is the balancing point idea, the center of mass. If your distribution is symmetric, the mean will be roughly in the center of the distribution, so right in the middle. If the distribution is skewed, though, the mean may be off to the right or to the left. To calculate the mean, you add all of your data values together, and then you divide by however many data values there are. So you have probably calculated the mean before, but maybe you just called it the average. We've seen these graphs, but let's look at them again and let's think about mean in terms of the balancing point. Like, where do we think the average SAT score is? Well, if you notice, the SAT scores are very much symmetrical. So what we know is that the mean should be right about in the center. It looks like right about in the center here would be somewhere maybe like 1450. Let's say. Now in the earthquakes, notice this is not symmetric. This is definitely a right skewed histogram. So what happens there is if we were to average out all of these different earthquake magnitudes, we wouldn't get exactly the center. We have from 0 to 7 here, we wouldn't get 3.5. But instead, maybe we would get something like, I think maybe it would be about maybe 2.2 or something like that. I don't think the mean would be quite here, but I think it would be pulled up. What happens with skew is that it pulls your mean, your average, up a bit. So in the skew distribution, the center of balance is not a good way of measuring the typical value. So it says, recall, another way of thinking about center of a distribution is to think about the halfway point or the middle. So the median is the value that's right in the center or right in the middle if you sort your data from the smallest to the largest. The median is a better measure of center for skewed distributions because it is what we call, quote, resistant to outliers. So let's kind of see what happens. If you've got a symmetric data set, your mean and your median are actually the same and they're both right in the center. So the average and also the literal middle value, if I line them all up from left to right, are going to be basically the same. Okay, so they may not be exactly the same. They may be off just a tad because, again, most real life data is not perfectly symmetrical, but they should be very close. Now, if you have very clear left skew, what will happen is that skew will pull this mean, it pulls that mean down, but it leaves the median kind of with the bulk of the data. So notice that the average now is way down here where all these data values are starting to fall off. Do I think these data values down here represent what's going on with this data? Probably not so much. These data values are not very popular. The median, though, sort of stays. It stays with the bulk of your data. So the median is then preferred when you have skew because it doesn't get pulled left or right nearly as badly. Same thing with right skew. If you have right skew going on, you have these few higher values. They're going to pull that mean up so that now it doesn't really represent what's going on. But the median will sort of stay. So that is what we really just want to be aware of, is that there are two different measurements for center. There's the mean, which is best used if you have symmetric data. And then there's the median, which we would prefer to use if we have either skew or outliers going on, because those things mess up the mean. Okay, to calculate the median, how do we do that? You sort your data from smallest to largest. If there's an odd number of values, the median should be right in the center. And if there happens to be an even number of observed values, to find the median, you average out the middle two values. So let's just do an example. The nice thing about these examples right now is that the data's already been sorted from smallest to largest for us. So if that's not the case, you can't just find the middle. You have to first sort it. So these are both sorted. That's good. Okay, we want to find both the mean and the median. So let's see. In order to find the mean, that requires a calculation. So I'm going to bring up my calculator. To find the mean, we have to add all those values together and then divide by how many there are. So the mean in this case, I'm going to do 1 plus 1 plus 2 plus 5 plus 7, 9, 11, 12, 12, 14, and 20. Add all those up. So we get 94. And then how many data values are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. And 94 divided by 11 gives us approximately, I'm going to round it off, 8.5, I'm going to say 8.55. So watch for rounding directions. Okay, and then if we want to find the median, that's actually most of the time easier. When you're finding the median, if they're already lined up from smallest to largest, just start picking them off from either end until you arrive in the middle. So like I'm going to cross them off as I go, outside working my way in. And what I arrive at in the very center is 9. Okay, let's go ahead and do the second data set for the mean of this data set. Again, I want to add all of these together. So we have 1 plus 3, oops, plus 5 plus 5 plus 7, 9, 2 12s, 15 and 16, and 2 18s. So if I add all that up, I get 121. And divide that by, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data values. So divide that by 12. And we get, I'm going to round this to 10.08. Double check that I got everything on that one. 9, 12, 12, 15, 16, 18, and 18. Looks good, I believe. Okay, then if we want to find the median, I'm going to do the same thing. I'm going to start picking them off from the outside in. However, on this one, since there are an even amount of data values, there is no one single middle value. So the median is the average of whatever happens to be in the middle there. So we're going to have 9 plus 12 over 2 in this case, which is 21 over 2, which is 10.5. So if you notice on both of these, look how close the mean and the median came out together. So we had 8.55 and 9, and we had 10.08 and 10.5. So both of these, the mean and the medians are fairly close, I would say. Like one's not drastically been pulled in one direction or the other. So I would say these are both fairly symmetric. And I haven't even looked at a graph, But just by looking at how their mean and medians compare and how they're fairly close to each other, I would say if we did like a histogram or a dot plot for these, they would come out looking mostly symmetric.